Hi, good morning. As part of the group assignments, I will be presenting this topic on some pump for underground drainage. Now, the scope of my presentation will start with introduction, the importance of underground pump drainage, and what are the principles of this pump sump drainage. Finally, we look at the design of pumps for underground drainage and pump and drainage maintenance, and finally, the conclusion. Now, what is an underground drainage system? Now, it's the one that excludes water, and usually this is the surface water, okay, from the lower levels of the building structure. Now, what I mean by lower levels is actually it will be usually at the basement level, now, at the lowest level of the building structure. And this is done by channeling water through a series of cut-off drains to a sump where the water is excluded. Now, the purpose of this is actually to prevent flooding at the lower levels, which actually could lead to a loss of properties and inhibit a growth of waterborne diseases caused by stagnant water. If the water is stagnant and it cannot come out, then this would be the result. Now, this is what happens when you do not have or you have inadequate pump system, or the pump is malfunction, or maybe even the drainage system is clogged or something like that. Now, this could be the result. You can see that here there's a Lucky Plaza. It was more than a decade ago. See the shops, have to even uh, prevent water from coming in. And also, you look at this condo here, there's this car park. Well, a lot of expensive cars are affected by the flooding. Now, even the MRT tunnels, they are not exempted from this. Now, now, what are actually the sources of this influx of water? It could be rainwater, storm water, especially when your basement is exposed to this. Water from washing, maybe washing the car park or washing the basement. Then water from fire sprinklers or firefighting would be in the event of a fire. Then sometimes maybe you have a water pipe burst or clogging, you know, and seepage to basement structures. Now, this seepage is very negligible. So we are not really into this, but we are more important in the event of a storm water, because these are actually the one of the largest quantities of the influx of water. Just for example, these are some of the basement car parks we're looking at. Now you see all these ramp down or these access, these are exposed to the weather, exposed to the sky. Same as this. This one is the second photo is actually taken at Nian. You know. So you can see that this is the ideal the place of the water that goes in, that possibly potentially flood the basement. Okay, there's a cross section, a simplified cross section. There's this a building line, and outside the building line is where the catchment, we call it the catchment area. Catchment area is the area that they collect the rainwater. So this rainwater or storm water, we call it, it comes in, and the water flow downwards, intercepted by this cutoff drain, and then this cutoff drain will actually channel the water into the so-called pipe, internal pipes, and then through the sump here. Now, and then this pump will actually pump the water out, onto the ground. Now you can see on the right there's this foundation drain. There's this water coming in. Now as I said earlier on, we are not looking into this because the amount of water is very negligible. So we are actually looking at the storm water. Now, this is a basement floor plan of the pump sump location. Okay, now as far as possible, this if this ramp is actually exposed to the weather, you know, we try to locate the pump sump as close as possible or next to the ramp where they intercept the water quickly and then pump the water out. You know, now we can actually locate this pump sump far further away into the car park. But the problem is, let's say if this cut-off drains or the pipes if they are overwhelmed, or where they are choked, then um, there will be flooding in the car park, before before the water actually goes into the sump. So it's very important to locate this just next to the ramp, to intercept the water quickly. Okay, the next thing we talk about is actually the design of the pumps. Now, the design of the pumps, we require one very important variable, and that is the flow rate. Now, this flow rate, we actually got it from the civil engineer. Now, as FM, we make sure that this pump is actually designed for this flow rate. You know, okay. Now, this flow rate is actually a function of a few parameters, which I will not go into. Now, this is under hydrology. If you are interested, you can ask me later. But this flow rate is the one that we are interested to talk about because this one will affect your rating of the pump. And actually, the larger the catchment area or the rainfall duration, the higher will be the flow. So the size of the pump will be also to be higher. Now, the design of the pump for underground drainage. Now, this is a function of the operating head, right? And also, your pump efficiency will also play a very important part. So to make sure that we select the pump which of higher rating, and also to ensure that these pumps are operated efficiently. Now, it depends on also on the flow rate of the water coming in. So in other words, we might need more than one pump just in case one of the pump is malfunction. We have another pump to operate. This is just an illustration of what are the head the water height to be considered when you size up the pump. Now it's actually the function of your flow rate and actually your height. Now this is actually the so-called the static height. But must remember that the water when we pump it, the water is not static. It is flowing. So we need to also consider friction losses and also any separation losses through the pipe. So in other words, our design H, it could be significantly higher than this to account for the effect of the friction losses. Okay, now, as I talked about earlier, we have seen cases of flooding, the basement, and one of our important mission as FM is make sure that the pump don't fail. In order the pump must not fail, it must be always operating. Now, in order to ensure that the pump will not fail, then we could make sure that these things are done, regularly, you know, at least, okay, firstly, we look at the cut-off drains. Now, this one is make sure that they are clear of any obstruction. And also electrical connection, make sure that it must be always turned on. Water depth sensors, make sure that the minimum water depth is assured for the pump to work. Also, the pressure gauges and flow meter, to measure the pressure and the flow. And for the pump itself, we look at the pump mounting, the connections, and also the connection with the outlet pipe, make sure they are properly sealed and there's no leakage. And also within the pump, there's seals and packing, and there are other accessories in the pump that like the rotor fan blade condition, lubrication, and also presence of any residues inside the housing. Now, the some of these items like the pump seals and the bearing, they could be checked once every 3 months. Others they are more need to have more frequent checks to make sure that the system is viable. Now, in conclusion, I want to say that the quantity of storm water, when the quantity of storm water we estimate, it may not be 100% accurate because there's some degree of uncertainty, especially when it comes to rainfall. There's always it's based on probability. But our duty as FM is to make sure that there must be adequacy of some pumping and drainage system to minimize any flooding. So, and therefore, proper and regular pump maintenance and a well-maintained drainage system will actually go a long way to mitigate loss of space, loss of properties, and any adverse environmental effects. So very important, pump maintenance. Uh, Make sure that the sanitary pipes are not choked. Make sure that they are unobstructed. Okay, that's the end of my presentation. Thank you very much.